Hello, Mr. Wright here, and welcome to this walkthrough of the Maths IGCSE paper 1FR. That's a foundation paper from January 2022. You can download the paper by clicking a link in the description, and then you can work on the paper and then watch the film, or you can work on the paper as you watch the film and work alongside me. If you're sitting your Edexcel IGCSE Maths soon, hit like now. Let me know you're watching and help the channel by hitting like. And if you've got any questions as you watch the film or as you're working on the paper, leave them in the comments and of course I'll respond. Right, let's get on with the maths. Okay, question 1. Right, from the numbers in the box, write down an even number. Well, you could have 10 or 28. A multiple of 9, a number which 9 goes into, a number which is in your 9 times table. You could have 27. 3 9s are 27. Okay. A prime number. Now, a prime number is a number which has 2 factors. Exactly 2. Not 1 factor, so not 1, but 2 factors. So your choices here are 23. In fact, that is the only prime number there, 23. Here are 4 cards. Each card has a number on it. The 4 cards are arranged to make the number 7,358. Yes, they are. Show how the 4 cards can be arranged to make the smallest number using all the 4 cards. Well, I want the fewest possible hundreds. Then I'll need to use the 5, then the 7, and then the 8. Show how the 4 cards can be arranged to make a correct calculation below. A 2-digit number plus a 2-digit number equals 95. Well, you could do trial and error, of course, if you wanted to. You could look for 2 numbers which will work in the units to give you a 5. I'm thinking if I have one ending in a 7 and one ending in an 8, then if I added those up, something 7 plus something 8, I'd end up with 5 down here and 1 in the 10, so that would end in a 5. So then perhaps, should I try the 37 and the 58? That will work. Or you could have 57 and 38 as well. And that is question 1. Let's have a look at question 2. Here are 3 shapes. Shape A is a triangle. Yes, I agree. Write down the mathematical name for this type of triangle. Well, it's got 2 equal sides, so it's an isosceles. Shape B is a rectangle. On shape B, draw its lines of symmetry. So it's going to have a line of symmetry vertically there and a line of symmetry horizontally there. It is not going to have a diagonal line of symmetry. Do not be tempted to do that. Shape C is a regular polygon. Yes, I can see it. Now it's actually, what sort of polygon is it? It's got 5 sides, hasn't it? So it's a pentagon. But that's not what it's asking me. It's write down the order of rotational symmetry. So if I rotated it, how many times would it land on itself as it went round once? And the answer is 5 times. And that's question 2. Question 3. Change 6 meters into centimeters. Well, each meter is 100 centimeters. So 6 meters is 600 centimeters. Change 4,500 grams into kilograms. Well, every 1,000 grams is a kilogram. So 4,000 grams is 4 kilograms, and 4,500 grams is 4.5 kilograms. Lauren has 3 litres of fruit juice. She's going to use the fruit juice to make some drinks for a party. Each cup of drink will contain this many millilitres of fruit juice. Well, I'm tempted to, sometimes I say, read a sentence, do some maths. I'm tempted to do some maths now without even reading the rest of the question. But let's just have a think about what maths we could do. She's got 3 litres of fruit juice, right? 3 litres, well, that's 3,000 millilitres. And each drink contains 225 millilitres. So I could, I bet this is what the question is going to be, I could say, well, how many drinks could she make? And I could do 3,000 divided by 225. And I can see that she could make 13.333 drinks. 13 drinks, and she'd have a bit of juice left over. Let's have a look. Lauren is going to make as many cups of drink as possible. Work out how much fruit juice Lauren has left when she's made as many cups. So I've already worked out she could make 13 drinks. Now, if she made 13 drinks, that would use this many milliliters of juice, 13 times 225. So she would have used 2,925 milliliters. And the question is, how much would she have left? Well, she started with 3,000. So how much would she have left? I'm going to do 3,000 minus 2,925, not 22, to tell me that she has 75 milliliters of the juice left. Okay, that's question 3 done. Okay, question 4. 40 people were asked to name their favourite type of holiday. So there are 40 people here. The pictogram gives information about the number of these people who said each of city break, beach, or walking. Ah, look, this is going to be important. One of those represents 4 people. So how much is each small square? Each small square must be 1 person, mustn't it? How many of these people said beach? Well, each one of those large squares is 4 people, 4 people, 4 people, 4 people. Oh, and 2 more people. So that's 12 plus 2, 14 people said beach. Okay. 4 people said cruise. 9 people said skiing. Show this information on the pictogram. Right, if 4 people said cruise, then that's going to be one of these large squares. That's what stands for 4 people, isn't it? There we go. Okay. And 9 people said skiing, so that's 4 of them. Another 4 of them, that makes 8. So 1 more little square makes 9. 1 person from the 40 people is selected at random. Find the probability that this person said city break. Well, how many people said city break? Let's have a look. I'm looking up here. 4, 5, 6, 7 people out of the 40 people altogether. So the probability that the person said city break is 7/40. 7 out of 40. And that's question 4 done. Question 5. Here are the first 4 terms of a number sequence. 7, 12, 17, 22. I'm wondering, just a minute. Let's just have a look. What's it going up in? Plus 5. Is it 5 every time? I think it is. Yes, it is. Okay, so it's going to go plus 5 then. All right, let's read the question. Write down the next term of the sequence. Oh, okay. It's going to be 22 plus 5, 27. Explain how you worked out the answer. I added 5. Is 226 a number of in the sequence? Well, let's have a look at the numbers in the sequence. They're 7, 12, 17, 22, 27, 30. Look, I notice what they always end in. They either end in a 7 or they end in a 2. They never end in a 6. So is 256 a number in the sequence? No. It says tick one of the boxes, so I better do what it says. So I'm going to put a tick in this box. Give a reason for your answer. Well, I would write something like, the numbers in the sequence always end with a 7 or a 2, and 256 ends in a 6. That would be my answers for number 5. Question 6. Write down these numbers in order of size. Now, sometimes I find it easier if they've all got 3 decimal, if the longest ones have got 3 digits after the point. Sometimes I find it easier to think about adding zeros in, so they all will have 3 digits after the point. And then it's a bit of a cheat, but now I just kind of look at the number after the point. So I think of that one, as being 470. This one as being 400, 740, 477, and 407. It's not very mathematical, but it works. So start with the smallest. Now the smallest is 0.4. Tick it to say I've done it. Now I've got 470. Well, it's 0.470. Done that one. That's 0.7. That's not good. That's 400. What, that one or that one? I'm choosing between these ones. So it's going to be 0.407. I've done that one. 470 or 477? 470. So 0.47. 0.477. I've done that one. I've done that one. So now I'm just left with 0.74. Write 0.7 as a fraction. 7/10. Write 30 as a fraction of 48. Okay, 30 out of 48. Give your fraction in its simplest form. Well, you could use your calculator for this. Put 13 over 48 in your calculator. Sorry, put 30 over 48 in your calculator and press equals, and it will cancel it down for you. Or you could have divided top and bottom by 6. Right, 23% is the decimal. Well, that is 23 hundredths. So you can simply write 0.23. And that is question 6. Question 7 coming up. Rita. Oh, this isn't question 7 at all. This is question 6 continued. Never mind. Rita has some beads in a bag. Of these beads, Rita gives a half to Sheng and 2/5 to Tusker. She now has 3 beads left. Work out how many beads she originally had. Well, there are a couple of ways we could do this. We could work out what fraction of her beads she's given away. We could do a half plus 2/5. We could do that on a calculator, right? A half plus 2/5. So far, she has given away 9/10 of her beads. And she's got 3, so she's obviously got 1/10 of her beads left. And we know that 1/10 of her beads, the fraction she has left, is 3 beads. So if 1/10 of the bag was 3 beads, then the whole bag must have been 30 beads. So that's one way we could do it. Or you could, if you wanted to, you could draw her bag out and you could say, well, I'm dealing with halves and fifths, so I'll split all this into tenths. Something like that. Is that 10? 10? Yes, more or less. They're not very even, are they? But never mind. Now, she's given a half to Sheng, so she's given those to Sheng, and then she's given 2/5, so that's going to be 4 of the tenths. So she's given that lot to Tusco, so she's left with a 10th, and that's 3 beads. And then you can see it's 30 in all. Personally, I find this way a bit easier, but it's up to you. And that is the end of question 6. Question 7. Right. Simplify. Right, what have I got here? I've got 3 C's. Have I got any, oops, have I got any more C's? I've got 3 C's here and minus a C. So altogether, that's 2 C's. And then I've got some D's. I've got plus 5D and another plus 2D gives me plus 7D. So there's my answer. 8E times 5F. 8 5s are 40. It's 40EF. Now solve this equation. Now I'm going to do this by floating and pinging, but you might solve equations in different ways. It's up to you. I'm going to float and ping the minus 3. So now I've got 5R equals, it becomes a plus 3. 5R equals 11. And then I'm going to escalate down the 5. So R is 11 over 5. That would be an okay answer. Or you could put it in your calculator if you wanted to, and you would get 2.2. All right, let's move on to question 8. Angles and triangles. Let's have a look. ABC, that's this line, is a straight line. Well, it looks like a straight line, doesn't it? And BCD is a triangle. Well, it looks like a triangle. I'm going to tick off both of those. Right. Work out the value of x. Not sure what to do. But just a minute. Could I work out the size of this angle here? Because it's 180 in a triangle. So I'm going to do 180 minus the 42 minus the 93. And so this angle is 45. And now I can do 180 minus 45 because I know that there are 180 degrees on this straight line. So 180 minus 45, 135 degrees for x. Okay. PO, RO, SO, and TO are 4 straight lines. Yes, they look like it. I've read that. Work out the value of y. Oh, no, wait a minute. Look at this. Isn't this all the way around there 360 degrees? So can't I do 360 degrees minus all the other angles? I think I can. And do we know what this angle is here? Yes, we do. It's 90. So I can do 360 minus 114 minus 90 minus 100. Okay, just stick that in my calculator. 360 minus 114 minus 90 minus 100. Gives me an answer of 56. Give a reason for your answer. I would write something like, there are 360 degrees around a point. Something like that. So I did 360 degrees minus all the angles that I knew. That's pretty good. And that is question 8. Let's move on to question 9. In November, Andre received a monthly salary of 2,500 euros. Okay, I've understood that. I've got that in my head. Of this, he spent 40% on his rent and 300 euros on leisure. Okay, let's read a sentence, do some maths. Should we work out how much he spent on his rent? I don't know what the question is yet, but I bet that you're going to want to know how much he spent on his rent. So that's 40% of 2,500. 0.4 times 2,500. So he spent 1,000 euros on rent, and he spent 300 euros on leisure. Okay. The rest of Andre's monthly salary. Stop. I wonder how much he had left. Let's have a look. What is the rest of his salary? The rest. Well, he started with 2,500. He spent £1,000 on his rent and 300 on leisure. Means that he has 2,500 minus 1,000 minus 300. He's got the rest of his monthly salary is 1,200, and he spends this on household bills and food, where the amount spent on household bills to the amount spent on food is 3 to 7. Right. Bills, food, 3 to 7 adds up to 10, right? Work out how much of his November monthly salary he spent on food. Well, bills, food, 3 to 7 adds to 10, and he's not spending a total of 10 on bills and food. He's spending a total of 1,200. So what's that been multiplied by? 1,200 divided by 10. It's been multiplied by 120. So that's multiplied by 120. That's multiplied by 120. So how much did he spend on food? 7 times 120. 7 times 120 equals 840 euros spent on food. And that is number 9 done. Question 10, Venn diagrams. Let's have a look. 50 students have lessons at a dance school. Okay. 2 of the lessons are ballet and tap. Oh, look, ballet and tap. Of the 50 students, underline that. Remember, we've got 50 students to deal with here. 31 have ballet lessons. Oh, can I write 31 here? No, because if you write 31 there, that is 31 having ballet. But remember, these ones, they also have ballet. So you can't just write the 31 in there. 31 have ballet. 27 have tap. 18 have ballet and tap. Complete the Venn diagram. So where can I put what? 18 have ballet and tap, so I can write 18 here, look. Great. Now, if 18 have ballet and tap, let's go back to the beginning. 31 have ballet. Can I write 31 there? If you do, then that would suggest that 31 plus 18, 49 had ballet. And 49 don't have ballet. Only 31 have ballet. So to work out what goes here, I'm going to work out what goes there. I'm going to have to do 31 minus 18. So 13 have just ballet, 18 have ballet and tap, and hence 31 have ballet, 31 altogether have ballet. What about this bit of information? 27 have tap. Well, 18 of those are already accounted for. 27 minus 18, 9 must go there. So I think I've done it, haven't I? But wait a minute. There's a little dotted line here. They're expecting something there. What's going on there? 50 students have to be in this Venn diagram altogether, don't they? Have we included all the 50? 13 plus 18 plus 9 is 31 plus 9 is 40. We've only included 40 students, so there must be 10 who don't do ballet and don't do tap. And that is my 3 marks on question 10. Question 11. The table shows information about the number of eggs laid by each of 36 hens. The frequency should add up to 36 in 1 week. So some of the hens didn't lay any eggs at all. 5 of them laid no eggs. Some of the hens laid 5 eggs each. How many hens laid 5 eggs each? 6 hens laid 5 eggs each. Work out the mean number of eggs. Well, we're going to need to know the total number of eggs laid. Now, if 5 hens laid 0 eggs, that's 0 eggs laid so far. 5 hens laid 1 egg. 5 times 1 is 5. 3 hens laid 2 eggs, so that's 6 eggs in total. I'm timesing, aren't I? 10 hens, 10 threes are 30. 4 sevens are 28. 5 sixes are 30. So this tells me how many eggs were laid in total by the 36 hens. So I'm just adding up that column now. I make that 99 eggs laid by the 36 hens. So the mean number of eggs is 99 divided by 36. So the mean number of eggs is 2.75 eggs per hen. Some people make a mistake and they think they're going to divide by the number of rows. 1, 2, 3, 4, 5, 6. They think they're going to divide by 6. Now, if you did divide by 6, then you would get an answer of 16.5. And I hope you'd look at that and you'd say, no way is the mean number of eggs 16.5. Each hen doesn't lay 16.5 eggs, because look, none of the hens lay more than 5 eggs. So I hope you'd realise that that was an impossible answer to have, and so you'd think, I've made a mistake somewhere. Number 12 coming up. Number 12. Describe fully the single transformation that maps A onto B. We have to go from A to B. It's going to be a reflection, and now just a question of where my mirror line is. My mirror line is going to be halfway between the two shapes, in the middle of the two shapes. It's going to be there, and that is the line that crosses the x-axis at -1. So it's the line x equals -1. So what's the transformation? It's a reflection. Get a mark for saying reflection. Reflect A in the line x equals -1. On the grid above, enlarge triangle A with a scale factor of 2 and a center 0. Right. So the center's at the origin. I'm going to do this in a different color. The center's at the origin here. I'm going to draw a ray line here. Do you notice how it goes 2 along, 4 up? So 2 along, 4 up. There we go. So this point here is going to end up here, double the distance from the origin. And now I've got that one. I can probably draw the rest of the shape now because it's a scale factor of 2. So you see how this was 3. So the new height, the height of the new one will be double that. It will be 6. So it's there. And then you see how this is got a base of 2. Well, the new one will have a base of double that, a base of 4. So it's there. And so that is it going to straighten? No. So that is my triangle here, my enlarged triangle. It says label your triangle C. I better do what they tell me. And that is question 12. Question 13. Factorize. That means put brackets in. 6x minus 15. Well, I can take 3 out of both of those expressions. 3 times 2x minus 5 is my answer there. And I can check to see that there are no remaining common factors. So I know that I've factorized it completely. And I have. There are 200 bolts in each box of bolts. Samira buys C boxes of bolts. Wait a minute. Read the question, do some maths. There are 200 bolts in a box. She's bought C boxes. So altogether, she has bought how many bolts? Well, if there's C boxes and 200 in each, she has bought 200 times C bolts. 200 C bolts. She uses the bolts she bought to fill packets of bolts. What? Oh, okay. She buys boxes, 200. She buys C boxes, and now she's filling packets. There are 50 bolts in each packet of bolts. Samira sells D packets of bolts. Well, she starts with 200C, right? Okay. And she sells D packets of bolts. So how many bolts does she sell? There are 50 bolts in each packet, and she sells D packets. So she sells 50D. So what does she have left? Because it says the total number of bolts she has left is T. So T, the amount she'll have left, will be the amount she started with minus the amount she sells. And that is the answer to number 13. Question 14. Let's have a look. It says, work out the value of that. Write down all the figures on your calculator display. So, I'm going to put that into my calculator very carefully. I'm going to put the whole thing in. So I've got the square root of 7.4. Move out of the square root. Plus, use the fraction operation. 5.1 squared on the numerator of my fraction. Move to the denominator, the bottom of my fraction, and put 3. Now I'm going to press, I'm just checking that I've put it in exactly right. And now I'm going to press equals, and I get 11.390291. And that is question 14 done. Question 15. N is an integer. That means it's a whole number, doesn't it? Tick that. Say I've got that in my brain. Find all the values of n so that n lies between -2 and 3. But remember, it includes -2 because n has to be greater than or equal to -2. So n could be -2, -1, 0, 1, 2, but not 3 because n has to be less than 3, not less than or equal to. On the number line, represent the inequality y is less than or equal to 1. So y is down here, isn't it? Less than 1. But it's less than or equal to, so I'm going to shade in there to say it includes the 1. And that is number 15. Let's look at number 7. Let's look at number 16. Each time John plays a game, the probability he wins is 0.65. Read some sentence, do some maths. What can you work out? I can work out the probability that he loses. I think so. Depends if you can draw. So let's ignore that for a moment. Each time John plays a game, the probability that he wins is 0.65. He's going to play the game 300 times. Work out an estimate for the number of games he wins. Well, the probability of him winning is 0.65. So out of 300 games, we would expect him to win that number of games. 0.65 times 300. 195 games. More than half the games, because it's 65% of the games, isn't it? And that is question 16. Question 17. Right, I'm looking at this and I'm seeing some right-angled triangles, and it says here, look, the shaded shape, there's the shaded shape, is made using 3 identical right-angled triangles. Where are they? 1, 2, 3, and a square. Here's the square. So I understand that sentence. Work out the perimeter of the shaded shape. Now the perimeter is the total of all the side lengths, isn't it? It's if I walk around the shape. So let's have a think about what information I've been given here. So I've been given that this is 16 and that's 16. So I could walk around those two, couldn't I? I know that's 16. I don't know this length here or that length. And I don't know that length. So I'm a bit stuck at the minute. Okay. But wait a minute, what's this 12.8 here? That 12.8. I think that is the length from here to here. Yes, it is. So let's look at this right-angled triangle. Let's draw it out. So it's got a hypotenuse, it's got a base, and it's got a height. Well, I know that the hypotenuse is 16, and I know the height is 12.8. So I can find this length here using Pythagoras. And I've done it in yellow because it's that length, which is the same as the other yellow lengths, isn't it? So I know the hypotenuse here. So I'm finding one of the two shorter sides. So it's going to be a subtract Pythagoras. So I'm going to do 16 squared, take away 12.8 squared, and then I'm going to square root my answer. Square root answer equals, and I get 9.6. So that length is 9.6. Right, so I know 9.6 and I know 9.6, right? So now, can I find the perimeter now, I wonder? Let's rub out all this and let's see what I know and what I don't. So, can I walk around the shape? Actually, what? I'll walk from here. Yes, 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 no. Now, what is that shape? Well, I know that this bit is 9.6. Look, and I know the whole thing is 12.8, right? So this little bit here is 12.8 minus 9.6. Do that on my calculator. 12.8 minus 9.6, 3.2. So let's label that now. Here we go. Get rid of everything. 3.2. Now, do I know all the lengths now? That one was 9.6. I think I do, don't I? I can walk around all the shape now and add up as I go. So I'm going to do 16 plus 16. Let's write these down. 16 plus 16 plus 9.6 plus 9.6. 9.6 plus 9.6 plus 16. That's this one. And then plus 3.2. And I've gone all the way around then. Plus 16 plus 3.2. So I'm just going to put that into my calculator now. 16 plus 16 plus 9.6 plus 9.6 plus 16 plus 3.2 gives me 70.4 centimeters. And that is my answer, 70.4 centimeters. And that's question 17. Question 18. Complete the table of values for y equals x squared minus 4x plus 3. Well, people do these in different ways. I tend to use the table function on my calculator. So I'm going to define fx, and I'm going to write in the fx is x squared minus 4x plus 3. And then on the table, I get to type in what I want. I want x to be minus 2, in which case I get 15. Now I'm going to check. I'm going to put x as minus 1 in, and it does give me 8. So I know that I'm getting the formula right in my calculator. I'm going to put x as 0 in, and it does give me 3. So I'm feeling pretty good about this. X is 1, gives me 0. X is 2, gives me minus 1. X is 3, let's check. Yeah, I get 0. And x is 4, gives me 3. Now, if you don't like to use the table function on your calculator, maybe you do them manually. And so maybe you would go, when you do x squared minus 4x plus 3, maybe you're going to do minus 2 squared minus 4 times minus 2 plus 3 on your calculator. If you do it that way, remember to put that in brackets. Otherwise, your calculator will give you the wrong answer. Right, I've got all my points there. On the grid, draw the graph. Oh no, look out! Different scales, look. So beware. Right, here we go. Minus 2, 15. Minus 2 along, 15 up. Minus 1, 8. Make sure you don't mess up your scale. 0, 3. 1 along, 0 up. 2, minus 1. 3, 0. 3 along, 0 up. 4, 3. And now I need to join all those up. It's going to be tricky on the screen. I'm going to try and join them up with a smooth curve going through the points like that. That's not too bad. And that would be 4 marks for question 18. Question 19. Yusuf sat 8 examinations. Remember, it's 8. Here are the marks for 5 of them. Okay. Now, for his results in all 8 examinations, the mode is 80. So, he must have got more 80s than anything else, right? So he must have got at least one more 80. Now, how many exams have he done? 8. So far, we've got 6 there, haven't we? The median of his marks is 74. So we know that 74, which is here, by the way, is halfway between his fifth and his 4th. Lucky, because it's going to have to be something, 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 something. We know it's 80. We know it's 80. Well, we don't know that yet, but let me show you. We know that the median, which is this one, in between those two, is 74, right? So we know he has to have at least 2 80s. He has to have a 77. He has to have a 75. And so that is all of these ones taken care of, because you have to have the 75 after the 74. Right. That's 75. The median's 74. So the 74, go down 1. The 74 has to be halfway between those two. So this one must be 73. We haven't got a 73, have we? So now we're going to have somewhere here a 68 and somewhere here a 72. And then another number. I've used the mode. I've used the median. The range is 16. Right. So from here to here is 16. Well, what's 80 minus 16? Let's have a look. 80 minus 16. His lowest mark must be 64. We haven't had a 64 yet, so that must be 64. So the 68 and the 72 must fit in here. It's quite a tricky question, isn't it? But those are his marks on all 8 exams. And now it says, find his marks for the other 3 examinations. So which ones were they? Well, one of them was 80. 75. One of them was 73. And one of them was 64. So his 3 other marks are 64, 73, and 80. That's quite a hard 4 marks, I think. But there you are. That's how to do it. Number 20. Work out the lowest common multiple of 36 and 120. Right, I'm going to write 36 as a product of primes, and I'm going to do that using my calculator and the format button. So I'm going to do 36 equals, go to format, go to prime factor, and it tells me that 36 is 2 squared minus 3 squared. If you've got an older model calculator, then you can do it using the fact button. Now 120 equals format, prime factor, 2 cubed times 3 times 5. So now I'm going to use the Venn diagram method. I'm going to put these in a Venn diagram. Okay, I'm going to have the factors of 36 in this one. I'm going to have the factors of 120 in this one. Okay, and now they've both got a 2 and a 2 in them. 120 needs another 2. They've both got a 3. 36 needs another 3. And now 120 needs a 5. So the lowest common multiple, remember if you're doing a Venn diagram, let me do that bigger so you can show you properly. If you're using the Venn diagram method, you can remember this diagram. LCM, HCF. The H goes in the highest spot, the L goes in the left-hand spot. And that tells me that LCM is all of those. So 3 times 2 times 2 times 3 times 2 times 5. 360 is the lowest common multiple of 120 and 36. Right. Let's have a look at this one. This one looks like it's going to be a tricky 2 marks. I'm pleased it's only 2 marks. Let's have a go. So we have got A, which is 5 squared times 7 to the 4 times 11 to a mystery power. And we've got B, which is 5 to a mystery, 7 to n minus 5, another mystery, and 11 to the 1. Now it tells us that m, n, and p are whole numbers, and m is greater than 2. Well, if m is greater than 2, then m, this one, could be anything. 3, 4, 5, 6, couldn't it? And so on. N is greater than 10, and p is greater than 1. Now, if you're finding the highest common factor, it's going to involve the lowest power of each of your factors. So you see, if it tells us that m is greater than 2, then let's say that was 5. Well, the highest common factor, the one that's in both, would be 5 squared, wouldn't it? It doesn't matter how high this is. The powers of 5 in the highest common factor will be limited by the fact you've got 5 squared there. Now, if n is greater than 10, then that means that the 7 in this second factor, it was n minus 5, must be 5 or more. Well, again, then your 7s in the highest common factor will be limited by this one. So you can only have 7 to the 4. And then if it tells you that p is greater than 1, so maybe this 11 here, maybe it's to the power of 4, I don't know, anything greater than 1, then the power of 11 in your HCF will be limited by that. So your highest common factor is going to be 5 squared times 7 to the 4 times 11. Find the highest common factor of A and B, give your answer as a product of powers of its prime factors. Done. Question 21. Millie is going on a car journey. She's going from A to B. Then she's going from B to C. Then she's going from C to D. Okay. From A to B, she drives 2.45 kilometers, distance 245, time 2.5. Okay. For the next leg of the journey, 220 kilometers at that speed. 220 kilometers, that's the distance, and her speed is 80 kilometers per hour. And then for the last leg of the journey, her speed is 72 kilometers an hour. And her time, 50 minutes. I have to put that in hours, don't I? 50/60ths of an hour. That's how long the time is there. Work out Millie's average speed in kilometers per hour for the whole journey. Give your answer correct to one decimal place. I'm going to need to use the daddy triangle here. Dad's a saint. Distance, speed, time. Okay. Sometimes I refer to this triangle, mass, density, volume, as the mummy triangle. Mum's a devil. But in this case, we're going to use the distance, speed, time triangle, which I remember by going Dad's a saint, ST for saint. Now, if we're going to work out her average speed for the whole journey, then we're going to need to know the whole distance and the whole time. Now, what do we know about the distance? Well, from A to B, it's 245. From B to C, it's 220. Oh, I don't know the distance from C to D, look. But I can find it. To do distance, I do speed times time, so it'll be 72 times 50/60ths. So that'll find my distance for me. Do that on my calculator. 72 times 50/60 gives me a distance of 60 kilometers. So her whole distance is 245 plus 220 plus 60. 525 kilometers. Now I need to know her total amount of just a minute. That's her whole distance. So why am I writing it where it says t equals? That's her whole distance. Now let's work out her whole time. Her time for A to B is 2.5. Now, I don't know her time from B to C, but I've got the distance and the speed. And look at the daddy triangle here. The time here will be distance divided by speed. So her time there, 220 divided by 80, is 2.75 hours. So far her time has been 2.5 for A to B, 2.75 hours for the next bit, and then 50/60ths of an hour for the last bit. So what's her total time there? Let's have a look. 2.5 plus 2.75 plus 50/60 gives me a total time of, well, I get on my calculator 6.08333 and so on hours. So now I'm going to find the average speed. The average speed for the whole journey will be the whole distance divided by the total time. 525 divided by 6.08333. I've got enough decimal places there to make sure it's accurate. Gives me 83.301, so to one decimal place, 83.3 kilometers an hour. Question 22, standard form. Write 5 times 10 to the 4 as an ordinary number. Well, you could use your calculator, I imagine, but I know, and so do you, that it's 50,000. 0.00006 is standard form. It's going to be 6 times 10 to the what? Go backwards. 1, 2, 3, 4, 5. 6 times 10 to the minus 5. And you could put that in your calculator and check that it gives you this as an answer. Work out this. Now, they've got very good recently at giving you calculations with standard form that you can't work out just by putting them straight into your calculator. And this is one of those examples. So what you'll have to do is you'll have to think about it like this. It's 4 times that divided by 1.6 times that. Now 4 divided by 1.6, you can do that on your calculator, and you get the answer 2.5. And then 10 to the 512 divided by 10 to the 700. Do you remember what you do to the powers, the indices? When you divide, you minus them, don't you? So it's 512 minus 700. So it'll be 10 to the power of minus 188. And that is in standard form, look, because I've got the 2.5. So there's my answer. 2.5 times 10 to the minus 188. Question 23. Simplify powers. When I multiply, I add the powers. Now, something cubed is something times, oops, I've written that down wrong. Try again, shall I? Something cubed is something times something times something. If you write that down, you're halfway to the right answer. 4 times 4 times 4 is 64. Y squared times y squared times y squared is y to the 6. Add the powers. Right, factorize this. Right, n squared minus 7n plus 12. Now, I know it's going to be n and n. I know they multiply to a plus and they add to a minus, so it's going to be minus minus. And then it's just a question of figuring out what it's going to be, 3 and 4, because that's going to give me the plus 12, and it will also give me minus 7n. And that is question 23. Question 24. Jonty has a storage container in the shape of a cuboid as shown in the diagram. Right, I understand that. Jonty is going to paint the outside of his storage container apart from the base. And the base is shown shaded. Yes, I understand that. He needs enough paint to cover the 4 sides and the top. Each tin of paint covers an area of 15 square meters. Well, wait a minute. Read a sentence, do some maths. Should we do some maths? Let's work out how many tins of paint he'd need. We better work out the area he's going to paint. The area he's going to paint. Now, he's going to do that end, isn't he? That has an area of 3.25. And he's going to paint the other end as well. So far, he's got 3 times 2.5 for one end, plus another 3 times 2.5 for the other end. Good. He's going to have to do the front, isn't he? This one. What's that going to be? 3 times 12. And he's also going to have to do the back. So that's another 3 times 12. And now he's just left with the top. Now the top measures 2.5 by 12. Look, that's the top. So he's going to have to add 2.5 times 12. So what's his whole area that he's got to paint going to be? I'll put all that in my calculator. So 3 times 2.5 plus 3 times 2.5 plus 3 times 12 plus 3 times 12 plus 2.5 times 12. His whole area is 117 square meters. And each tin of paint covers 15, right? 15 square meters. So if I divide by 15, then I'm going to work out how many tins of paint he needs. How many tins? 117 divided by 15. He needs 7.8 tins. So he's going to need to buy 8 tins, isn't he? Okay, you can't buy 0.8 of a tin. So he needs to buy 8 tins. The cost of each tin of paint recently increased by 10%. After the increase, the cost is that. Jonty says, before the increase, I could have bought enough paint for less than £200. Well, how much was the paint before the increase? Let's have a look. So, here's the paint before the increase. It gets increased by 10%. And now, a tin of paint costs £26.95. So this is a reverse percentage change. To go forwards, I'd multiply by 1 point the increase. So to go backwards, I'm going to divide. So I'm going to do 26.95 divided by 1.10 to find out how much the paint cost before the increase. 26.95 divided by 26.95 divided by 1.10. So before the increase, the paint cost £24.50 a tin. 8 tins. He would have to have bought, wouldn't he? 8 times £24.50. So before the increase, how much would he have needed? 8 times £24.50. He'd have needed £196, wouldn't he? Before the increase, I could have bought enough paint for less than £200. Yes, he could, couldn't he? Because it would have cost him £196. Show that Jonty is correct. We've done that. Show you're working clearly. And then so we could write his cost before the increase would have been £196. Therefore, he is correct. And that would get us our 6 marks for question 24. And that is the end of the paper. Well done for making it through to the end of the paper. Now, the details of the grade boundaries are in the description of this film. So if you look at the description of the film, you can see what the grade boundaries are for this set of papers, and then you can work out what grade you would have got had you been sitting the paper in January 2022. If you've got any questions, please leave them in the comments, and of course I'll respond. And if you are taking your IGCSE soon, or if you found the film useful, please hit like. Let me know you're watching. Right, that's all for now. Thanks for watching. See you in the next film.